everyone. So in this video, we're going to look at how to display quantitative variables. And we're going to look at 4 different types of plots. We have histograms, which are by far the most common that we're going to look at. We're going to use this throughout the entire semester. We also have stem and leaf diagrams, dot plots, and box plots. Now, box plots we're going to look at in Chapter 4, so I'm not going to talk about them in this video. So we're just going to look at the other 3, mainly histograms, but we'll do a little bit with stem and leaf diagrams and dot plots. So histograms. Histograms show us the distribution of the data. I want you to notice that histograms do look a little bit like bar graphs, but there's no space between the bars. The bars are the same width all the way, every bar is the same width, but again, there's no space between them. If there is a space, like right here, it's because this bin is considered to be empty. So a histogram is made up of bins, and we can determine the width of the bin. So I show you here 2 histograms. The bins in the histogram here, the bin width is 2.5. And you can see that between 10 and 20 here, we've got 1, 2, 3, 4 bins, which means that each bin width was 2.5. Whereas over on this one, we have a bin width from 10 to 20. So we have a bin width of 10. So we determine the bin widths, and then we look at the number of data points that fit within that bin. And we use what's called a right-hand rule. So for example, say that I have a data value that's exactly on the edge of one of these bins. So let's say I've got a data value of 30. Well, which bin does it go in? Does it go in this one or does it go in this one? Well, with a right-hand rule, what it's saying is that it's included in the right side of the bin. So 30 would be here in this bin and not in the other one. So let me get out my eraser. So it is not here. So I also wanted to just kind of point out that the bin width can sometimes change the shape of our graph. Maybe not change the shape, but take out some of the detail. We don't necessarily want a bin width that's too narrow, then sometimes it's just too much detail. But a bin width that's really wide, like this one again, it kind of leaves out some of this detail down here that could be important. Now, at the same time, keep in mind that this data set that I'm using, I guess I should have pointed that out in the beginning, I'm looking at the combined fuel efficiency in miles per gallon. So again, this is from that data set that I had in the first video. There was the size of that data set was, 1,273. So it's a large data set. So that did allow me to kind of play with the bin width a little bit. If you have a really small data set, if there's only 20 data values, it might be necessary for the bin width to be wide. And we'll look at histograms on our calculator with a small set of data, and the width will look wide, but that's just because it's a small data set. So typically I don't mess around with the bin width. I allow the technology to choose the appropriate bin width. It usually does a really good job. The 2 other types of plots that we look at in this chapter are a stem and leaf diagram and a dot plot. Just like the histogram, they both show us the distribution or the shape of the distribution of the data set. They just do it a little bit differently. Let's talk about the stem and leaf diagram first. So what the stem and leaf diagram does is it kind of pulls off the tens value and puts it over here on the left. So for example, when I'm looking at this first row right here, I've got a 5, 3, and an 8. That means the data values that made this up were 53 and 58. For the next row, the data values were 60, 65, and 68. So it basically take that tens value off, and they're kind of creating a bin width of 10 here and then putting those data values in. I want you to notice that I switched data sets. This is a data set for life expectancy, which was not on that original data set that I showed you. And that's because I couldn't create a stem and leaf diagram for the combined fuel efficiency because these only work for small data sets. If I were to make a stem and leaf diagram of the data set that I had for these histograms, the numbers would have gone off the page. It would have been unusable. So these work for small data sets. They are nice though because they show us the actual data values within each bin. A histogram doesn't do that. If you'll notice, I know you can't tell that I'm doing this, but if you were to turn the stem and leaf diagram to the side, it does kind of look like a histogram, right? It kind of has that same type of shape where we have these bins here. And so it does still show the shape, but it really only works for small data sets. The same thing is happening with dot plots. This is where we use dots to basically plot the values. Again, I had to change data sets because I couldn't make a dot plot with a data set that was a size 1,273. That was just too many dots and it would have gone off the page. So basically when you have data values of the same value, like this looks like it'd be about, 182? There's 3 182s. So it does show you a little bit more of the specific data values. Again, only works for small data sets. All right, so we're going to do an example here. And we are going to we're going to create a stem and leaf diagram by hand. And then I'm going to show you how to create a histogram using your graphing calculator. So in this example, it says students in a biology class kept a record of the height in centimeters of plants for a class experiment. And so we have, this is size 20 here. We have 20 heights for these plants in centimeters. So looking across here, we've got values in the 30s, 40s, 50s, 60s, and one value at 75. So when we make this stem and leaf diagram, I'm going to start with a 3, a 4, 5, 6, and a 7. And then we're going to use the ones value from each of these data values to create the leaves here. So let's see, we've got a 38, a 36, and a 32. So putting these in order, I would write a 2, a 6, and an 8. And I'm trying to keep these equally distant apart here. Looking at the 40s, I've got a lot of 40s here. So we've got like a 49, 41, a 43, 48, 44, 48, 48. All right, so if we put those in order, we've got a 41, 43, a 44, 3 48s, 1, 2, 3, and a 49. So again, I'm trying to keep everything equidistant apart here so we can get a good visualization of the shape of this distribution. We also have a lot of 50s here. So we've got a 55. I'm trying to make this a different indicator here. 55, 54, 56, 52, 53, 59. All right, so I heard myself say 52, 53, 54, 55, 56, and a 59. All right, I think I got them all. Then we've got a 67, a 62, and a 60. So putting those in order, we've got a 60, a 62, and a 67. And then finally we have this 75. So there is my stem and leaf diagram. If I turn it to the side, it kind of looks like a histogram with a bin width of 10. All right, now creating a histogram on our calculator. Let's see if we can't see a similar shape between the two. So I've got the steps here. The first step is that we're going to enter all this data into L1. And I actually already did that on the calculator here because you don't want to sit and watch me just enter data. Then we're going to go to stat plot, which is right up there. And we're going to turn it on. We're going to turn on one of the stat plots and choose histogram. And then once we have that stat plot set up, we're going to go to this button here that says zoom. We're going to go to zoom and choose 9, which is called zoom stat. So I have this all on this calculator here, and I'm going to run the video of me doing this earlier. So I'm going up to stat, I'm hitting edit so that I can enter the data into L1, which I already did. Then I'm going to go up to second stat plot. Notice that all the plots are off. Let me just stop this for a second. Notice that all the plots are off right here. You don't want more than one plot on at the same time. So we're going to turn plot 1 on, but we want the others to be off. So we're going to go into plot 1. We're going to highlight on and hit enter. And then we're going to arrow over to the histogram and hit enter again. Now I've set the stat plot, and notice that the X list, again, hold on. Let me go back just a little bit. I want you to notice that after I hit the histogram, the X list turned to L1, which is where I have my data. The frequency is 1 because I don't have any frequency list, so I just leave that as 1. Which means now my plot 1 is set. Once plot 1 is set, then we're actually going to go to zoom and hit zoom 9. So I go up to zoom, go down to zoom stat, which you can arrow down or just hit the number 9, and we have our histogram. And you can see that the shape of this histogram is very similar to the shape of the stem and leaf plot if I were to turn that stem and leaf plot 90 degrees counterclockwise. It is slightly different, so you can tell that there's not a bin width of 10 in the histogram, but it looks very similar.